Welcome to the General Chemistry Theory class. This section is on chemical kinetics. This lesson is about the first order reaction. Let's begin. In this lesson, we will write the rate law for first order reaction. Recall that a first order reaction obeys the following rate laws. Doubling the reactant concentration doubles the rate of reaction. The concentration of reactant in a first-order reaction decreases exponentially with time. The graph shows that the amount of A will never deplete even if a very long time has elapsed. Sample problem. Example number 1. The conversion of an organic thiocyanate to an organic isothiocyanate at 90 degrees Celsius is found to obey first-order kinetics. A 0.0010 mole per liter solution of thiocyanate was allowed to react. How much thiocyanate remains after 3000 seconds? The rate constant is 3.2 times 10 raised to negative 4 inverse second. Solution. What is asked in the problem is the concentration of the thiocyanate at 3000 seconds. We can apply the integrated rate law to solve the problem. Plugging in the initial concentration, rate constant, and time, we get the concentration being equal to 3.8 times 10 raised to negative 4 moles per liter. The integrated rate law for a first-order reaction can be converted to its linear form by taking the natural logarithm of both sides. Applying laws of logarithm, the linear form of the integrated rate law is given by the natural logarithm of concentration of a time t is equals to natural logarithm of initial concentration of A minus kT. A reaction is of first order if the natural logarithm of reactant concentration plotted against time gives a linear graph. The slope of the line is equals to the negative value of the rate constant. Sample problem number 2. The decomposition of hydrogen peroxide has an order of 1, giving that hydrogen peroxide concentration equals 1.72 moles per liter at time equals 400 seconds, and hydrogen peroxide concentration equals 0.98 moles per liter at time equals 1200 seconds. Write the differential rate law that is obeyed by the reaction. Indicate the value of the rate constant. Solution. Since the reaction is first order, the plot of in H2O2 against time is linear. Use the given concentrations at different times to calculate the slope. The natural logarithm of hydrogen peroxide concentration is at the y-axis, while t is at the x-axis. The slope equals change in y over change in x, which is equal to negative 7.03 times 10 raised to negative 4 inverse second. Reversing the sign of the slope gives the rate constant. Thus, the rate constant equals 7.03 times 10 raised to negative 4 inverse second. Write the differential rate law with the calculated rate constant. Different. The rate of reaction equals 7.03 times 10 raised to negative 4 inverse second times the concentration of hydrogen peroxide. Some reaction with an overall order of 2 can obey first law, kinetics under some conditions. Such reactions are referred to as pseudo-first order reactions. For reaction to be a pseudo-first order, a reactant must be present in large excess. The concentration of this reactant can be incorporated in the rate constant. Consider the hydrolysis of ethyl acetate to produce acetic acid and ethanol. The reaction is second order overall. first order with respect to ethyl acetate, and first order with respect to water. Since the concentration of water is too high, that is, remains constant throughout reaction, the rate law can be produced to rate equals K prime times the concentration of ethyl acetate, where K equals K times the concentration of water. At this state, the reaction is now of pseudo-first order. Higher order reaction can also behave like a pseudo-first order reaction if the concentration of other reactant or reactants is keeping constant. For reaction A plus B plus C yielding products, which is third order overall, first order with respect to each reactant. Keeping the concentrations of B and C constant makes the reaction behave as a pseudo-first order reaction. To summarize, first order reactions are reactions of order 1. Throughout the course of the reaction, reactant concentration is consumed exponentially with time. Second or higher order reactions can be reduced to pseudo-first order reactions by keeping the concentration of certain reactants constant in their reaction. References? That would be all. Thank you. Welcome to the General Chemistry 2 class. This quiz is about the first order reaction. Let's begin. Question number 1. A first order reaction is a reaction whose rate law is rate equals K times concentration of A raised to the exponent n, where n is equals to 0. Question number 2. Which of the concentration time plots on the right correctly represents the reactant concentration throughout the course of first order reaction? Select the correct answer. Question number 3. Which of the following equations is the linear form of the integrated rate law for a first order reaction? Select the correct answer. Question number 4. In the linear form of the integrated rate law for a first order reaction, the slope is equal to blank. Select the correct answer. Question number 5. Determine if the statement is true or false. The concentration of the reactant in a first order reaction can be equal to 0. Question number 6. For a reaction with the rate law, rate equals Kt, where K is equals to 1.43 times 10 raised to negative 2 inverse second. What concentration of T remains 634 seconds after 0.020 moles per liter of T is allowed to react? Select the correct answer. Question number 7. What is the rate law for the first order reaction M forming P given the concentration of M equals 0.19 moles per liter at time equals 45 seconds and concentration of M equals 0.0075 mole per liter at time equals 88 seconds? Select the correct answer. Question number 8. What is the rate law for the first order reaction Q forming R given that concentration of Q equals 0.19 moles per liter at time equals 23 minutes and concentration of Q equals 0.12 moles per liter at time equals 37 minutes? Select the correct answer. Question number 9. Determine if the statement is true or false. For the reaction S plus T, yielding products with rate law given by rate equals K times concentration of S times concentration of T, the reaction becomes a pseudo first-order reaction if either concentration of S or T is held constant throughout the reaction. Lastly, question number 10. For the reaction A plus B yielding products, whose rate law is given by rate equals K times concentration of A times concentration of B squared, which of the following is the rate law if the reaction is reduced to a pseudo first order reaction? That would be all. Thank you.